How does an ultrasonic sensor work? Well, step one, the sensor has to send out a short burst of sound. Usually in ultrasonic sensors, that would be at around 40,000 hertz or 40 kilohertz. After that, the sound travels through the air at the speed of sound and hits an object. Step three, after the sound hits an object, it bounces off the object and returns to the sensor. Step four, the sound returns to the sensor and the sensor picks up that the sound returned. After that, in the computer, we calculate distance. How do we do that? Well, distance equals the speed of sound, which is around 343 meters per second at room temperature, times the time of flight. That means the time it took for the sound wave to go and come back, to divide by 2. That's it. This simple mathematical equation gives us the distance. Now, why do we divide by 2? Well, the time of flight is the time for the sound to go there and back. But we want to know the distance of the object only there. We don't want to know there and back. That's why we divide by 2. To get into specifics of how the HC-SR04 sensor works is like this. The sensor itself has 4 pins: power pin, VCC, ground, and then a trigger pin and an echo pin. The computer gives a short 10 microsecond pulse on the trigger pin. That causes the sensor to send out a sound wave. After that happens, and the second the sensor sends out a sound wave, the echo pin goes high. Now it stays high until the sound wave returns to the sensor. In figure 2, you can see that more clearly. We have an uptick for the trigger pin, and then the echo pin goes up right then, and it stays high until the sound wave comes back. Now, the echo pin tells us how long the time of flight was. We put that into the equation we just saw here for time, and we do speed of sound times the time that the echo pin was high to divide by 2. That's it. Now I want to show you some examples of how we could do this calculation using an oscilloscope. So I want to demonstrate now how we could measure the distance by just using an oscilloscope. So I have here a plate. We'll put it, say, at 40 centimeters. Okay, now the sound will bounce off that plate and go back to the sensor. So let's just pause the oscilloscope and zoom in. Fantastic, and I'll take a picture of that and we'll analyze it together on the computer. We got from the sensor. So as you can see on channel 2, which is connected to the trigger pin, we have a 10 microsecond pulse, which goes up to 5 volts. Now, as you remember, this is what sends out the sound wave, okay? And once the sound wave goes out, the echo pin, which is channel 1, goes up to 5 volts, okay, till the signal comes back, okay? So let's see how long that took. So each box is 1 millisecond, as you can see here on top. So we have 1 millisecond, 2 milliseconds, 2.2, around 2.35, okay, milliseconds. So let's do the math of what the distance is, okay? So we have 2.35 milliseconds. So to turn it into seconds, let's divide by 1,000, okay? Now let's do times the speed of sound, which is around 343 at room temperature, okay? And then let's divide by 2 to get 0.4 meters, which is 40 centimeters. Isn't that amazing? As you saw in the video, I stretched out a measuring tape and I put the plate exactly on 40 centimeters. And this is exactly what we're getting just by analyzing the signal from the oscilloscope that we get from the sensor. Great, so I want to give one more example. Now let's try even closer. Let's try 20 centimeters. So you put the plate at 20 centimeters and let's catch it. Okay, I'll zoom in and show it to you guys on the computer. Fantastic, so let's analyze this signal now. Again, we can see on channel 2 the trigger pin, which triggers the sound wave. On channel 1, we could see that it was high for, again, each box is 1 millisecond, so it's 1.2, I would say, is my best guess. So let's do now, I'm gonna get the calculator fully on the screen. Let's do 1.2 2 milliseconds. To get it into seconds, we need to divide by 1,000, and then times 343, and to divide by 2, and again, unbelievable, 0.20 meters, which is 20 centimeters. So again, just by analyzing the signal we get from the ultrasonic sensor, we could determine the distance.